Hi, I'm going to do something that they do at the very last section of chapter 6. They do it in print and you can read it there, but I think it's much easier to actually see than to read, so I want to show it to you. Now, none of this is going to be on the test, but it might still be helpful for you. It might give you a better understanding or richer understanding of the 6 fallacies, the 6 logical rules for fallacies that we looked at near the end of chapter 6. And you also might find it interesting. So I'm going to walk through this. It'll take a few minutes. What are we looking at here? We're looking at a spreadsheet with all 256 possible syllogisms. That is all the different forms that a syllogism can take. From AAA1 up in the top left corner, all the way down to over here you can see OOE4, but actually I've got a whole nother page of stuff further down below that. Now these are arranged in a kind of a pattern here. The top section right here is everything that has a conclusion of A. And then this section right here is everything that has a conclusion of E. And then below that is everything that has a conclusion of I and everything that has a conclusion of O. All right. What we're going to do is we're going to try to eliminate the invalid syllogisms. And we can do that without knowing what any of the A's or E's or I's or anything are talking about, because we can just look at the pattern of the form itself to figure that out. And we can apply those 6 rules just to what we see in terms of the letters. So we're going to take the 6 rules we have and use them to eliminate all the invalid syllogisms and see what we have left. Now over on the right hand side, to make it easier, I've listed the 4 figures. So what this means is that figure 1 starts with an M here and then has a P, and on the second statement there's an S followed by the M. So, and here's figure 2 and here's figure 3 and here's figure 2, here's figure 3, here's figure 4. That'll help us a little bit as we go. All right, I'm going to take these a little bit at a time, and we'll see how quickly we can eliminate whatever we can. So let me start with rule 4, I think, is the rule about not having 2 negative premises. You can't have a valid conclusion at all if you have a valid argument at all if you have 2 negative premises. So anything that starts with 2 negatives can't be valid. Now the negatives are the E and the O, right? E is negative, it's a none statement. O is negative, it's a some not statement. So anything that where the first 2 letters are both E, or they're both O, or one's an E and one's an O, those are all invalid. So that's all the EEs here and all the OEs here, and the same thing down below. So this entire column right here can be eliminated. And this entire column is EOs or OOs, so these can be eliminated. The second thing we know is that if one of the premises is negative, the conclusion also has to be. Now that won't pose any problem for the ones down here because they have a negative conclusion. So they can have a negative premise. But the ones up here have a conclusion of A, and A is affirmative. So that means you can't have a negative premise. So anything in the ones I just highlighted that has an E or an O in it has to be invalid. So I can take all the E's, all the ones here out because they have an E in them and end in an A. And I can take all the ones here out because they have an O in them and end in an A. And I can do the same thing here. Actually, anything that has an E and ends in an A or an O, I can take all these out here. So there go those. Okay, next. We know that we always have to distribute the middle term. So that means one of the first 2 premises has to distribute something, which means we can't have 2 I's in a row, because I's don't distribute anything. So we can't have both I's. One of them has to be something that distributes. So we can take these out. By the way, we can take those out down here too, because that's also true down here. Okay. Next, if we end with an A, then that means the conclusion is an all statement. And if the conclusion is an all statement, then it distributes the subject, that is the S. And if the S is distributed, and the M is distributed, we have to have 2 different things distributed. The S has to be distributed in the second statement, and the M has to be distributed in the first statement. So the first thing that tells me is neither of those 2 statements can be an I, because the I doesn't distribute anything, and I need the first statement to distribute the M, so that the second statement can distribute the S. So this I can immediately eliminate, because as an I, that's not enough to distribute everything that I need. And same thing for this one. So I only am left with these 4. Now, since they end with an A, they distribute the S. And the S is distributed in the second premise. So that means the second premise is also an A. So that means the second premise has to have an S where the A would distribute it, which is on the left. So what I'm saying is, of these figures, the only ones that will work are something that have the s on the left. So 1 will work because the s is on the left. 2 will work because the s is on the left. But 3 and 4 will not. So we can take 3 and 4 out. And then between 1 and 2, we know the s is distributed in the second one, but we know the m is distributed in the first one. So by the same reasoning, we have to have an m on the left. So we have an m on the left here, that's fine, but not here, so that's not fine. 2 would never distribute the middle. So we can take that one out as well. So the only thing that works for a conclusion of an all statement is to start with 2 alls as well, A1. Now when we come to the e's, we can eliminate everything so easily at the beginning, but we can take advantage of the fact that we know that an e distributes everything. So the conclusion here distributes both the subject and the predicate, and that tells us a lot. Because everything, according to Rule 3, everything that the conclusion distributes also has to be distributed in the premises. So the premises have to distribute the s and the p, but we also know from Rule 2 that they have to distribute the m. So all 3 things, the s and the p and the m, have to be distributed in those first 2 statements. So that means a couple of things. It means that at least one of them has to be an e. Because if you don't have at least one e, then you can only distribute one thing each, and that won't be enough to get all 3 things distributed. So anything without an e in the first 2 statements I can eliminate. So I guess everything from here to here to here I can take out because there's not an e in the first 2. And this one and this one I can take out because there's not an e in the first 2. And this one and this one I can take out because there's not an e in the first 2. Okay. The second thing we know is because you have to distribute 3 things in the first 2 statements, not only does one of them have to be an e, but the other one has to distribute at least something. So it can't be an I. So you can't have an e and an I together would only distribute 2 things, and we need 3 things distributed. So we can take this out, and we can take these out. Okay. So we're left with these 4 things. So let's think more about the distribution. If we distribute, we need to distribute subject, predicate, and middle. So in these over here, where we start with an A and then have the E, the A has to distribute the predicate because the predicate can only be distributed in that first statement. So the A has to distribute the predicate. And A's distribute what's on the left. So the predicate has to be on the left. So the only forms that'll work are the forms that have only figures that'll work are the figures that have the P on the left. So not 1, but 2. Not 3, but 4. So I can take out 1, and I can take out 3. By the same token over here, these have an A in the middle, and the middle has to distribute the subject. So the subject has to be in the left. So the only things that'll work is the ones with the S on the left. So 1 and 2 will work, but not 3, the S isn't on the left, and not 4. Otherwise, it wouldn't distribute what it needed to. So that I can eliminate it down to these 4. Let's keep going down below. Okay, the next set of statements we have are these. So let's start the same way we did before. We can't have 2 negatives in a row because that's never valid. So all these can be eliminated, and all these can be eliminated. We can do something else right away. I and O are both particular. And if you have a particular conclusion, you can't have 2 universal premises. So anything that has just A's or E's at the beginning can't be valid. So AA can't be valid, and AE can't be valid. So these we can take out. And down here, AA and AE we can take out. And up here, EA we can take out. And down here, EA we can take out. Okay. Next. I is affirmative. So if I is affirmative, you can't have any negative premise with it. So none of these with the O or the E, actually, or this one with the O, none of these can be valid. Nothing with an O or an E in it can be valid because we end with an affirmative. So I can take these out, and I can take these out. We don't have the same problem for the O's because those are negative anyway. We can't have two i's for the same reason as before. We have to distribute at least the middle. So we can't have two i's either here or here. All right. So let's think else. What else we have. If we end with an I, we don't distribute anything in the conclusion. So the only thing that's important is that we distribute the middle term. So if we have the I, if we start with an I followed by an A, then it's the A that has to distribute the middle term because the I can't. So the A always distributes the left-hand thing. So in the second premise, we have to start with the middle term. So that means the second row in our figure has to start with an M. So it can't be 1, can't be 2, it has to be 3 or 4. So I can take these out. Now, on the other hand, if we start with an A, then that's where the middle term has to be distributed, which means the middle term has to start, it has to be the left in the top premise. So we have to have middle at the top. So either 1 or 3, but not 2 or 4. Let's move down to the O's. Okay, O is particular. I already looked at that. Let's see. O's distribute something. They distribute the predicate. So anything that distributes the predicate, all these things distribute the predicate, but they also distribute the middle. So they'll all have to distribute at least two things. So they can distribute two things in a couple of ways. Well, let's first of all think about it. If they have an I, then the only other thing they can have has to be an E to distribute the other two things. So EI is fine because the I won't distribute anything, but the E will distribute both of the others. But OI won't work because you won't have enough to distribute two things. So we can take out all the OIs and we can take out all the IOs. And for exactly the same reason, we can take out all the AIs, it's not enough to distribute, and all the IAs, leaving us with this. Okay, let's see. The O distributes the predicate. So the predicate is in the first premise. So the first premise has to distribute something. So we can't start with an I. All right, so let's think about each of these small groups by itself. The O distributes the predicate. So the predicate has to be distributed in the premise. So in the first premise. So the first premise has to distribute the predicate. For these four, the first premise is an A. So the A distributes whatever's on the left. So of these, the predicate has to be on the left in the figure, and that's only figures 2 and 4. So we can take out 1, and we can take out 3. Over here, we distribute the predicate and we distribute the middle. The I doesn't distribute anything, but the E can distribute them both. So it doesn't matter what order they're in, we'll be able to distribute both middle and predicate in the top premise. So actually none of these pose a problem. Okay. Down here, we distribute the predicate, which means that it has to happen in the top premise, and that's an O, so the predicate has to be at the end of the top premise, so we have to end with a P. So that's either 1 or 3, it's not 2 or 4. And of 1 and 3, we also have to distribute the middle term with the A. So the middle term has to be on the left. So that doesn't work for 1, but it does work for 3. So I can take the 1 out. I think I missed that step over here. Let's check. Over here, the predicate is distributed at the top. So the A distributes the predicate. So that had to start with a P. But then also the middle term has to be distributed by the O in the middle. So that distributes the second thing. So the M has to be at the end. So the M is not at the end for 4, only for 2. So I can take this one out. Okay. Now, I think we're done. So let's count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And there's our 15 valid syllogisms. Okay, thanks.